Question number 16. A uniform bar of weight 200 Newton weight. Where is it now? This is your 4 meter. 200 Newton will act at the middle over here. This will be your 200 Newton. Okay, it's really hinged on one end the bar is horizontal and is held in equilibrium by a cable at a distance of 0.5 meters from the other end. Okay, so you are connecting it over here. The cable is at an angle of 35 degrees to the horizontal. Okay, what is the tension T in the cable? Okay, so what we need to do is we'll resolve this tension into two parts. One along this direction, which will be T cos 35, and along this direction, which will be T sin 35. Next, what we need to do? So we will just apply the moments formula. So how do I apply the equilibrium moments? Because there is no rotation here and there. I can just say T sin 35. This force multiplied by the perpendicular distance. What is the perpendicular distance? Here it is 0.5. This should be 3.5 here. Okay, multiplied by 3.5 should now be equal to this is 200 and which is acting in the middle. So this should be 200 multiplied by the length of it is 4 meter. So this length should be 2 meters multiplied by 2 meters. So thus you can say T is equal to 400 divided by 3.5 times sin 35. Okay, let us calculate this, which will give you the complete answer. So let us take this, and now what we do is we will take 3.5 sin 35. So sin 35, what is the value? Sin 35 is equal to so much. Then multiply this by 3.5, which will give you 2. Okay, so if this is 2, then this should be 400 by 2 should be equal to 200. The answer is C.